Welcome to section 913. We're going to be talking about writing the equations of these polynomials. Now, we're going to find the exact equation of these polynomials. So these polynomials are going to be in the form of like y equals a times a binomial times a binomial times a binomial and so forth. What we're going to need to do is we're going to need to find a. So what we're going to do is we can see based on the number of turning points that it has two turning points, so our degree is going to be 3. And our leading coefficient based on the shape is going to be a positive. Now we want to find the exact leading coefficient. And now my zeros, my x-intercepts, x equals, I get a -3, I see an x equals 0, and I see an x equals 2. They're not bouncing, none of them are being repeated. What I want to do is I need to solve for a. So what we're going to do, y equals a times x minus -3, they're my x's, x minus 0, x minus 2. So y equals a times x plus 3 times x minus 2. Now we need to solve for a. So to do that, we need to find another point on the graph. Now another point on the graph is this point up here at -2, 8. That'll go in for my x and my y. So 8 equals a, and it's going to be -2 plus 3, -2, -2 minus 2. So 8 equals a times 1 times -2 times -4. So 8 equals a times 1 times -2 times -4 is +8. Divide both sides by 8. A equals 1. So there we go. We found a. So our equation, y equals, so we can use this from right here. A is 1, so it's going to be 1 times. We don't need to write it. And you'll commonly see it written as x plus 3, x minus 2. Keep in mind, it doesn't have to be in that order because order doesn't matter for multiplication. Let's try another one. Now, we can see there's 1, 2, 3 turning points. So I know my degree is going to be odd, but I see it doing something weird here. Now, what's happening there is it's not going straight through, which means it's being repeated. So our zeros, x equals -3, x equals 0, and x equals 2. Now that 0 is going to be repeated 3 times. That 0 is repeated 3 times, and that's going to be important to recognize. So we need to find out what a equals. So y equals a times x minus -3, x minus 0, and that's going to be cubed, and x minus 2. So y equals a, and I'm going to rearrange this. X minus 0 cubed, that's going to be the same as x cubed. X plus 3, x minus 2. Now to solve for a, we're being given this point. There's my x and my y. So -32 equals a times -2 cubed, -2 plus 3, -2 minus 2. So -32 equals a times -2 to the third is -8 times 1 times -4. -32 equals 32a. Divide both sides by 32. A equals -1, which we kind of knew it was going to be a negative based on the way the graph went. So y equals, we're just going to put a negative there, x to the third x plus 3, and then x minus 2. There's our polynomial function in that factored form. Let's do another one. So we can see our turning points. There's 2. I don't see any weird parts going through, but I do see a bounce right here. So I know right away my degree is going to be 3 based on the number of turning points. And I know my leading coefficient is going to be a negative of some sort because of the way it's going, just like the last one. And now my zeros, x equals negative 2 and x equals 1. Now the negative 2, because of the bounce, that's repeated twice. So y equals a, x minus negative 2, and that's going to be squared, x minus 1. A times x plus 2 squared times x minus 1. Now, looking through, we need to find another point. And I see a point up here at 0, 8. So that's going to act as my x and my y. I can use any point as long as I know exactly where it is and not one of our intercepts. So for y, 8 equals a times 0 plus 2 squared times 0 minus 1. 8 equals a times 2 squared is 4 times negative 1. So 8 equals negative 4a. Divide both sides by negative 4. A equals negative 2. So our equation, y equals negative 2 times x plus 2 squared times x minus 1. And there is our polynomial function in standard form. Looking at problem number 3. These equations look identical, except for one thing. For the first equation, a is a positive 1, and for the second equation, a is a positive 3. So just like we talked about in previous sections with our value for a, what it means is that the second equation, or the second graph, has a vertical stretch. Now they both have same shape. They're both going to look something like this. The second one's just going to be stretched out. So they have the same shape, and they also have the same x-intercepts. The only thing is the other one's stretched. That's it. And let's do one more. Problem number 4. We're going to find the exact equation. Now we know that 1/16 is on the graph. Looking at the number of turning points I have, I know that my degree is going to be 4. And based on the shape, I can see the leading coefficient should be a positive. Now I don't know exactly what number it's going to be. That's what we're going to solve for. So my zeros, x equals negative 3, x equals negative 1, and x equals 2. Now, if you notice, it's bouncing there at 2, so that's repeated twice. So y equals a times x minus negative 3, x minus negative 1, and x minus 2, and that one's going to be squared. So y equals a times x plus 3, x plus 1, and then x minus 2 squared. Now I need to solve for a. So 1 is my x I'm going to use, and 16 is my y. So 16 equals a, 1 plus 3, 1 plus 1, and 1 minus 2 squared. A times 4 times 2 times negative 1 squared, which negative 1 squared, put that right there, is going to be a positive 1. So 16 equals 8a. Divide both sides by 8. A equals 2. So my equation, y equals 2. X plus 3 x plus 1 and x minus 2 squared. There's my polynomial function in in factored form. Okay, we'll do some more tomorrow in the next video. Thank you, and I'll see you in the next one.